In this tutorial, we'll use the aggregate functions mean, median, and mode as a workbook author in Oracle Fusion Data Intelligence, or FDI. Aggregate functions, like mean, median, and mode, perform calculations that summarize information in a dataset. For this example, I'm an HR analyst wanting to analyze salary distributions in US sales and marketing to identify disparities within 3 departments and across 8 job roles. Each role is assigned between 1 and 94 employees. I'll use this workbook in compensation planning to determine if the salary distribution is balanced or uneven. In my employee details table, I have employee salaries for all job roles in the 3 departments. I'll begin with a new canvas and create a table. On the data pane, I'll select the department and job columns and then drag them to the canvas. Under my calculations, I'll select the mean, or average salary, and the median, or middle salary measures that I have already created and drag them to the rows in the grammar panel under job. Next, I'll drag mode, or the most frequently occurring salary, which I also created as a measure, to rows in the grammar panel under the median salary. Finally, I'll drag numbers of employees to the rows in the grammar panel under mode salary. For visual clarity, I'll drag department to the color in the grammar panel. I notice that the values for mean salary and median salary are not displayed correctly. This is because there isn't a specific average aggregation defined to group the salaries in the expression editor. To confirm this, I'll go to the data pane, right-click the mean salary calculation, and select Edit Calculation. In the expression editor, I confirm the calculation uses average distinct for salary. This average distinct calculation will count each unique salary value only once when calculating the average. If I want every value included, not just the distinct ones, I can take out the distinct specifier from this function. I want to count distinct values, so I'll click Cancel without saving any changes. I'll repeat the previous steps for median salary and confirm there is no aggregation. Since I don't have the aggregation level I need in the expression editor for my calculations, I'm going to define the calculations in the visualization. I'll click the Properties icon, then Values. I'll select Mean Salary, then By and Auto. I need to make this function aggregate by job, by department, and additionally by employee salary, so I'll select Full Name. Finally, I'll ensure that the aggregation method for mean salary is set to average distinct. To the right of aggregation, I'll click Auto and then select average distinct. The table now displays mean and median salaries correctly, but because mode salary was created as a data flow, it didn't need to be updated. Since the mode function is not available as a predefined aggregation, I used Oracle Analytics Dataflow to calculate it. The process involves determining the most common salary per department and job by following these 4 steps. Now that I have applied the functions, I'll return to the table visualization to perform the analysis and interpretation. I identify that junior sales representatives in the Sales US department have a mean salary of $28,750, while the median salary is $32,500. Since the mean is lower than the median, this suggests the junior employees are underpaid compared to their peers. Here I find the sales managers in the Direct Sales US department have a mean salary of $51,750, but the mode salary is $58,500. Suggesting a significant number of sales managers earn more than average. And that's it. HR can use these insights to adjust salary structures, ensure fair pay across departments, and identify gaps in pay equity. Find additional tips and resources on using Fusion Data Intelligence in the links below.